Since from grade 1 we are learning numbers. We are counting numbers. We are learning different numbers. Those likewise, right? So all these numbers we have learned. We are familiar with the numbers. Decimals or fractions or symbols. Different types of numbers we have learned up to now. All these numbers, right? All the numbers we have learned up to now are called real numbers. They are real numbers. They are actual numbers. And please remember, all these numbers we call these numbers as real numbers. So, if we add an imaginary number, what is an imaginary number? Real number means it's a real one. It's an actual number. It's an actually there exists a number, so we call it as real number. Real number. We add an imaginary number to that. Imaginary means they doesn't exist. It's imaginary. It's an imaginary number. You have to imagine. It's an imagination. So if you add a real number and imaginary number together, listen carefully. If you add real number and imaginary number together, what are real numbers? All the numbers we have learned up to now. Decimals, full numbers, plus or minus numbers, fractions, all these things are real numbers. If you add an imaginary number to any real number, then we get a complex number. Once again, if you add a real number and an imaginary number together, you will get a complex number. Real number plus an imaginary number, you will get a complex number. So, finding the analysis or doing the algebraic things with the complex numbers are what we called as complex analysis. Complex analysis means dealing with the complex number, doing the mathematical or the algebraic activities with the complex numbers. That is what you call as complex number. To make a complex number, you have to add a real number and an imaginary number. Now, what is an imaginary number? Real numbers we know. Real numbers are what we have learned up to now. We are familiar with the real numbers. Now, complex number means a real number plus an imaginary number. So, we need to know what is an imaginary number. Normally, we denote complex numbers from Z. Right? Normally, complex numbers are denoted by Z. This is the standard notation. We use Z to denote complex number. Z is the complex number. So here it says Z equals X plus I times Y. X plus I times Y. So here X is our real number. Maybe 1, 2, 3, 4, 0.7, 0.6, 1 upon 2, 5, any real number. X be any real number. I times Y. So here I times Y is called as imaginary number. I times Y, always the imaginary numbers, there is a I sign there. The letter I, the sign is always there in an imaginary number. We have a real number called x. The imaginary number is I times y. I times any letter. That is what you called as an imaginary number. Imaginary number. They doesn't exist in the real world. But if you add them together, you will get a complex number. Complex number means the addition of a real number and an imaginary number. If you add a real number and imaginary number together, you will get a complex number. In standard notation, we denote complex number, a complex number as Z, real number as X, and the imaginary number as I times Y. Imaginary number is I times Y. So the real number, which is X, real number is X. If we get the real part, real number is so called as real part or the real section. We write it as RE, RE within brackets Z equals X. That means in this complex number Z, if you are given a complex number called Z, the real part of this Z is X. Now complex number is the addition of a real number and an imaginary number, right? So if I ask you, considering this complex number, what is the real section? That is X. Real section is X. Imaginary section, it is here. It is here. Any number multiplied by I is called as an imaginary number. Remember that any number multiplied by I is an imaginary number. I times Y is an imaginary number because we have multiplied the Y by the sign of I. Y is a normal number. If you take only Y, that is a normal real number. But if you multiply it with the sign I, then it becomes an imaginary number. Okay? So in the number Z, complex number, X is the real number, I times Y is the imaginary number. Real part is X. Imaginary part, now remember that, listen carefully. Imaginary number is I times Y. Imaginary part is Y. Only Y. Imaginary number is I times Y. Imaginary part is only Y because it has multiplied by I. Multiplying a number by the sign I becomes an imaginary number. In an imaginary number, what is the imaginary part? Imaginary part is Y. Carefully remember that. So in mathematics, we write it as RE, that means RE Z, real part of Z. In short terms, we write it as RE Z, real part of Z equals X. In imaginary part, if we take the imaginary part from the imaginary number, we can get imaginary part. Imaginary part is Y. We denote it as IMZ. IMZ is Y. REZ is X. Is that clear? Is that clear to you? Understand this very clearly. If you lost something here, then please ask. I will explain again. Don't make doubts over there. This is the very basic thing in complex analysis. So clearly understand this. I times y is the imaginary number. Y is the imaginary part. This is the imaginary part. This one, I times y, is the imaginary number. So if you want to get the real part of z, we write it as REZ, that is x, imaginary part, IMZ, that is y, that is the letter y. Is that clear? Can few of you respond me whether you got this or not?
Clear, madam.
That is clear. Okay. Anyone having any doubts? Okay, it seems not. But if you have anything, please ask. Right? Don't go with the doubt. Now, a complex number, a number of the form of z equals x plus iy is called a complex number. Right? Complex number when x and y are real numbers. Right? As I mentioned you earlier, x and y are real numbers, but if you multiply y with the sign I, then it becomes the imaginary number. If you take along x and y, both of them are real numbers. Both of them are real numbers. We'll try to understand this by an example, right? So that will be more clear to you. And it says I equals root of -1. Normally, when we are discussing the root, square root of a number, it should be a positive one. Right? When you are taking the square root of a particular number, that number should be a positive one. That's a positive one because we are not discussing the square root of negative numbers because they are not exist. That's an impossible. We couldn't take the square root of negative numbers in real analysis. So that means up to now we have learned, we have dealt with real numbers, we have done real analysis. In real analysis, when we are dealing with real numbers, then square root of a negative number is not real. It is not real. But in complex analysis, that's why I said, so in complex analysis, this is IY is the imaginary one. If you multiply I with a real number called Y, then it becomes imaginary because this is I is. Now, if you take I as a square root of -1, that doesn't exist. That's an imaginary one. So that is why we call I as an imaginary section, imaginary sign. If you multiply I means it equals square root of -1. Square root of -1 times I becomes the imaginary number. Now if we take I times Y, I equals square root of -1. Y is the real number. Y is the real number. I is the square root of -1. So what if you take the square of both sides? If you take I squared over there, then this becomes square root of -1 times square root of -1. Then it becomes -1. That means I squared equals -1. That means if you multiply I with I and square root of -1 with square root of -1, then you can remove the square root, you get -1. Therefore, I squared equals -1. We'll try to understand this by an example, right? Now a complex number is given as z equals 2 plus I times 3. Earlier we had z equals x plus I y, x plus I y. Now x has replaced by 2, y has replaced by 3. X has replaced by 2, y has replaced by 3. We have the real number. Sorry, here it should be real imaginary number, right? For a mistake, I have put it here imaginary part. Please correct that it is imaginary number. I times 3 is the imaginary number, and this is the real number. Clearly?
Yes, madam.
Okay. Now, for our easiness, normally when we are dealing with science, early in equations, you might remember we use 3 times x, 3x, 3 times x, 5 times x, 3x plus 5y. The sign we have used after the number. For our easiness, we can use the same. So z equals 2 plus I times 3. We can write it as 2 plus 3 times I. Same as 2x plus 5y plus 3z. You had solved problems, right, in derivatives. So likewise, we can write it as 3 times I. Either I times 3 or 3 times I, doesn't matter. For our easiness, because we are familiar to put the sign after the number, therefore we can use it as, we can write it as z equals 2 plus 3 times I. Doesn't matter. Now, another example. Now, if you understand clearly the earlier example, now tell me what is the real part of z and the imaginary part of z. For you, I can show you the earlier example. In the earlier example, now compare with the earlier example, we had z equals 2 plus I times 3 or 3 times I, whatever. Then the RE z, the real part of z, it becomes 2. Imaginary part became 3. That is our example. Now compare this example with this one and tell me what is the real part of z and imaginary part of z. Okay, first tell me what is real part of z. Someone? Real part of z.
Real part of Z is 4.
Mm-hmm.
Imaginary part of Z is 5.
Imaginary part of z is 5. Okay. Any other answers? Anyone having different answers? Or are you all agree with her answer?
Yes, madam.
Okay, correct. The real part of z is 4. Imaginary part of z is 5. That is simple, right? So if you are given a complex number, you have to write it in the form of a real number plus I times another number. Then the first number, the real number is the real part. Then you get a section called I times a particular number. So that number becomes the imaginary part of the complex number. Right? They are not much difficult. The only thing is, in the real numbers, we had only one section. In complex numbers, there's another addition with the sign of 5. That is all. Now, if we get an example like this, 2 minus 3 times I. 2 minus 3 times I. What will happen? Earlier, the format was x plus I times y. X plus I times I. Always the addition sign should be there. So if you get a negative number, then you can write it as, now here the negative sign is there. But in our format we learn a plus sign should be there. Therefore we have add a plus sign over there within brackets minus 3. Plus times minus, it becomes minus, no harm to the original equation, original number. This is same as the earlier one. So our complex number becomes 2 plus minus 3 times I. 2 plus minus 3 times I. So the real part, now the plus sign is there. Real part is 2. Imaginary part is 3. Sorry, minus 3. Always keep in your mind, in between the real part and the imaginary part, in between the real number and the imaginary number, the plus sign should be there. There should be a plus sign. Adding of real number to an imaginary number. So plus sign should be there. If the plus sign is not there, you can convert it. You can convert it into a plus sign like this based on your problem, and then find what is the real part and what is the imaginary part. So in this example, now we have converted it like this. So we get z equals 2 plus minus 3 times I. 2 plus minus 3 times I. So that real part becomes 2, imaginary part becomes minus 3. REZ is 2, IMZ is minus 3.